Okay, well, what did we learn the last two discussions we had? I want to hear some feedback.
Paul knows.
Caused the fire.
And what would lead you to conclude that, Dennis?
Everything you said.
That's an easy answer.
It does make sense.
It does make sense. Well, specifically, one of the things that I brought in was, since the late 90s, we've learned that the composition of a lot of comets actually are pretty rich in things like methane and ethane and acetylene. Now the question is, still in my mind, the thing that needs to be worked out is how can you get that from a comet to the atmosphere where it could actually become combustible. Now as far as methane is concerned, I think generally they talk about 3 to 5% of the atmosphere needs to be methane in order for it to become combustible.
Is that all?
That's all. That's all. So the question becomes how does that mechanism work? And that's the thing that I'm actually, I don't have a decisive answer on that yet, but I do think it's something that warrants further research.
It's cold in space.
It's cold in space. And if do anybody know what a methane hydrate is? Where you have a methane molecule locked up in a water molecule. I believe that would be the most fruitful avenue of research for coming up with a possible delivery mechanism by which you could get these deep frozen comet nuclei as they come into the Earth's atmosphere, they disintegrate and then release their cargo. I also think that it's necessary to have the appropriate conditions for it to do anything. I mean, if it came in over an ocean, it's not going to do much. If it comes in over an area, you see what made that fall of 1871 so appropriate was because it had been so dry. And you had this low pressure zone sort of stagnating over the whole central United States. And that almost, in my mind, could create almost like a funnel. Anything coming in gaseous could essentially be funneled over the Midwest. And then again in 1894, when you had the Great Hinckley fire, same deal. You had a situation where you had a very dry summer, so everything was dried out, and if you had obviously weather like this, I don't think it would do anything. So I think you have to have several conditions necessary, because I suspect that the accretion of gas to the Earth's atmosphere from comets may be a lot more prevalent than we've come to think. In fact, there's been recent research that there may be a lot more comets out there than was previously recognized that are essentially invisible because their crust is covered with dust. They're not reflective, and we don't know they're there. Well, we only got into a small part of the eyewitness accounts the last two times. I have really enough to turn this into a whole book, but a lot of the eyewitness accounts, very much talk about smelling the gas in the atmosphere, seeing these effects that would suggest that the atmosphere was saturated with gas. Pardon?
What does it smell like?
Well, I don't know what it smells like. I presume, what does methane smell like? Well, if it's methane, I don't know what acetylene smells like.
Swamp gas.
Swamp gas, yeah. Now see, there's another possibility, swamp gas. Now the question is could outgassing from swamps be enough to actually create levels of saturation in the atmosphere that could be combustible?
That would also depend on the location and how much swamp you got, right?
I would think so.
Swamps in Chicago.
No, but there are certainly swamps around Hinckley. That was one of the things that were, in fact, some of the survivors of the Hinckley fire took refuge in swamps. But, in Chicago, you had, descriptions of sheets of fire encompassing like a whole square block within a matter of seconds. And that is something considerably different than a normal fire. In each one of these cases, the fire were characterized by a number of things, one being the sheer intensity, the heat, being able to fuse like whole barrels full of nails that just completely fused into, in the Hinckley fire, there were train engines that essentially fused to the track. Now, what kind of a fire is going to cause the metal, the steel train wheels to melt and fuse with the track?
Some obvious.
What?
Hobbyist fire.
Oh, yeah. Probably not anything that we would consider to be a normal, even a normal forest fire. One of the big fire that was in 2002 out in Oregon burned up 350,000 acres, and it took almost a month to do it. Most of it was done in 3 weeks for the entire fire to run its course. That was considered one of the biggest fires of the last couple of decades. The Hinckley fire burned up roughly the same acreage in 4 hours. So, you know, again, when you begin to look at the specifics and the details of these fires, there's something very unusual about them. I mean, they're...
Like the sun just went.
Well, it wasn't the sun, but...
Okay, can you have just the exact opposite of that happening? For instance, we can go back to the demise of a lot of the mammoths, and they were killed instantly and frozen instantly.
Yes.
And there was one of the things that they have found out and I've done a lot of studying on this, that you put a piece of meat in your deep freeze, and in 6 months, it basically is spoiled.
Mm-hmm.
But here is an animal that's 6, 7, 8, 10,000 years old, and the meat is still edible. Now, what is the difference between the two meats? Do you know that?
Well, I think it's two things, how quickly it freezes and how cold it is.
Okay. The first thing is that when you put your piece of meat in the refrigerator, it freezes from the outside in. And the cell is the last thing it freezes. And there's no room for that cell to expand. And all the cells in meat in your refrigerator the cells are all busted in it. But these mammoths weren't.
Mm-hmm.
The mammoths, the cells were froze first and then the rest of it. And that's the difference. Now, could you have just the opposite of what we're talking about here?
Some kind of a comet-induced freezing?
That's right. And it takes about 280 degrees below 0 Fahrenheit to create that condition.
Mm-hmm. Yeah, it has to be extraordinarily cold.
Now.
Instantaneously.
That's right.
Well, and the Beresovka mammoth was found 1901, and it was 6 tons. It was still, as you probably are aware, that it was actually eating, flowering plants at the time it was frozen to death.
Buttercups in its stomach.
Yeah, it had 25 or 26 different varieties of plants in its stomach that hadn't putrefied. So, like you're saying, I mean, the evidence indicates that it froze very, very, very fast. And science has chosen not to really address itself to the question. They've come up with uniformitarian explanations that make no sense whatsoever. But yeah, I mean, I've thought about that, how you could, but again, be honest, I can't picture in my mind what the exact mechanism would be, other than some perhaps rapid delivery of gases from space that are near absolute zero in temperature.
How about comets or asteroids hitting and tilting the poles? So what was once Californian tropic is now like North Pole and freezing in an instant because all the...
That couldn't happen. Couldn't happen. No, I mean, there are pole shifts, but they're a drawn out affair. That's been proposed. That's been one of the ideas that's proposed, an instantaneous...
proposed that in 1970, 1957, 58, when he wrote the book, Earth in Upheaval. Postulated that whole concept.
Yeah. Well, like I said, I honestly don't know. And I wish that there was enough scientific interest in it to address itself to that question. It seems almost... maybe politically incorrect to, for a long time we've labored under the delusions of uniformitarianism, so geologists have been dissuaded from investigating catastrophic events only until the last 2 decades. And it seems like I've said this repeatedly, we actually know more about what killed the dinosaurs than what killed off the woolly mammoths. The dinosaurs of 65 million years ago, we know more about that than what killed the woolly mammoths 10,000 or 12,000 years ago. We saw these images, but we'll just sort of pick up from here because this is kind of where we left off. we clearly see that there is a tradition associating massive fires with comets. And I don't know how extensive this tradition is, but I've seen enough to convince me that the tradition does exist. That ancient peoples did believe that there was association between these outbreaks of these cosmic fires. This, I think, is really, in some respects, as important, more important perhaps even than learning about the Great Flood, because what is becoming apparent is that we basically live on a planet that's vulnerable to a whole variety of different kinds of global catastrophes. And what the climate record seems to be showing is that for the last 6 or 8 or perhaps 10,000 years, we've been in a period of relative calm. Although, as I'm going to show you some stuff I brought tonight that's cutting edge news, the calm of the Holocene has probably been interrupted several times. Actually, let me go ahead and read this to you here, because it's quite germane. In recent years, the fall of ancient civilizations has come to be viewed not as a failure of social engineering or political might, but rather the product of climate change and possibly heavenly happenstance. As this new thinking dawned, volcanoes and earthquakes were blamed at first. More recently, a 300-year drought has been the likely suspect. But now, more than ever, it appears a comet could be the culprit. One or more devastating impacts could have rocked the planet, chilled the air, and created unthinkable tsunamis, ocean waves hundreds of feet high. Showers of debris wafting through space, concentrated versions of the dust trails that create the Leonids, would have blocked the sun and delivered horrific rains of fire to Earth for years. Does anybody know when the Leonid meteor shower is?
October 8th?
No, that's the Draconid. This weekend. This weekend is the Leonids. So far, the comet theory lacks firm evidence, like a crater. Now, though, there is a depression that has been discovered in Iraq. It was found accidentally by Sharad Master, a geologist at the University of Witwatersrand in South Africa, while studying satellite images. Master says the crater bears the signature shape and look of an impact caused by a space rock. The finding has not been developed into a full-fledged scientific paper, however, nor has it undergone peer review. Scientists in several fields were excited by the possibility, but they expressed caution about interpreting the preliminary analysis and said a full scientific expedition to the site needs to be mounted to determine if the landforms do in fact represent an impact crater. And of course that won't be able to happen until the political and military situation in Iraq changes. Researchers would look for shards of melted sand and telltale quartz that had been shocked into existence. If it were a comet, the impact could have occurred on what was once a shallow sea, triggering massive flooding following the fire generated by the object's partial vaporization as it screamed through the atmosphere. If it proves to be an impact crater, there is a good chance it was dug from the planet less than 6,000 years ago, Master said, because shifting sediment in the region would have buried anything older. So if it was less than 6,000 years, now the crater appears to be about 2 miles wide. 2 miles wide would be a major explosion. Certainly well up into the multiple nuclear bomb range. Probably a 2 mile wide crater would be something on the order of 1 to 200 megatons at least, which is an enormous explosion. It would not be big enough to cause a global mass extinction. However, it certainly would be enough to cause a global climate change that would have lasted for several years, and it would have caused complete havoc within that region. Now, so the question is could we see, if this thing actually occurred somewhere around 6,000 years ago, the appearance of civilization in the Middle East around 4,500 years ago could essentially be interpreted as the restoration of whatever was there before, because whatever was there would have been pretty much destroyed. Perhaps there's a link here with the story of Sodom and Gomorrah, when fire and brimstone rained out of the sky and destroyed Sodom and Gomorrah. Let me go, let's see, 2 large impact craters in Argentina are believed to have been created sometime in the past 5,000 years. Benny Pizer, a social anthropologist at Liverpool John Moore University in England, said roughly a dozen craters are known to have been carved out during the past 10,000 years. Dating them precisely is nearly impossible with current technology. And Pizer said whether any of the impact craters thought to have been made in the past 10,000 years can be tied to a single comet is still unknown. However, one of the comets that perhaps has been linked with multiple impact events is Comet Encke, which is the progenitor, or at least part of, the Taurid meteor stream. What famous event was perhaps part of the Taurid stream? Do you guys remember from months ago? The Taurid stream perhaps delivered something to Earth. Yes. 1908, Siberia. That had all the earmarks of being a piece of the Taurid system, probably a piece of Comet Encke that came in we crossed the Taurid stream 2 times in a year, once coming and once going. Around June 30th is one of the dates, and around October 31st, November 1st is the other date, when the meteors from the Taurid system peak. I also remember, if you guys recall, some of you who were here, I presented some interesting evidence about the history and the origins of Halloween, perhaps being linked with the scenarios of the end of the world being associated with the Taurid meteor system. This next thing was in the New York Times yesterday. I haven't had a chance to actually go to the scientific sources yet, but this is quite interesting. At the southern end of Madagascar lie 4 enormous wedge-shaped sedimentary deposits called chevrons that are composed of material from the ocean floor. Each covers twice the area of Manhattan, with sediment as deep as the Chrysler Building is high. I think that's about 700 feet. On close inspection, the chevron deposits contain deep ocean microfossils that are fused with a medley of metals typically formed by cosmic impacts. And all of them point in the same direction, toward the middle of the Indian Ocean, where a newly discovered crater 18 miles in diameter lies 12,500 feet below the surface. Now, 18 miles in diameter,
How far down?
12,500 feet.
How far down is the one in the Chesapeake Bay?
Well, the one in Chesapeake Bay
It's
is,
not that deep, is it?
it's a half a mile deep, under half a mile of sediment.
It's a half a mile down to the top of the sediment.
It's a half a mile. The Chesapeake Bay crater is buried under 1/2 a mile of sediment. So if you're standing on the rim of Chesapeake Bay, under your feet, a half a mile down, is an ancient impact crater, 36 million years old, that's got a half a mile of sedimentary rock over it.
How much water?
Well, that water wouldn't have necessarily been there 35 million years ago. Well, there was water, but it wasn't the Chesapeake Bay as we now know it. It was a shallow sea that covered the coastal plain of the eastern United States. And I don't remember how deep that water was, but it would have passed right through the water, gouged a big hole.
The Chesapeake generally is not real deep.
No. And the Chesapeake Bay wasn't there. But I can go here, we can get an idea of the size. The Iraq crater, which is 2 miles, we can look here at a 2-mile crater. Here's 2.1, yeah, okay, at 2.1 miles is 125 megatons. So you know, the biggest hydrogen bomb ever detonated by the Soviets back in 1962 was 50 megatons. So this is 2.5 times that big, would create a 2-mile crater. So the crater in Iraq, if it does turn out to be a crater, and I would strongly suspect it will be, would have been like detonating 2 enormous hydrogen bombs. Notice though also that that is equivalent to 8,350 Hiroshima-sized bombs. So I mean, that'll give you some sense of how much power was there. Now, what about an 18-mile crater? Let's see what an 18-mile crater would be equivalent to. Let's see. There's 8 miles. Okay, here's 17.5 miles. Equivalent energy, 200,000 megatons. Over 13 million Hiroshima-sized bombs. What would that do to Earth's climate and atmosphere?
It would change everything for 100 years.
If not more. Okay, now, so they've discovered this 18-mile crater on the bottom of the Indian Ocean. These chevrons are sedimentary deposits that appear to be emanating directly from that area of the Indian Ocean. So all of them point in the same direction toward the middle of the Indian Ocean, where a newly discovered crater 18 miles in diameter lies 12,500 feet below the surface. The explanation is obvious to some scientists. A large asteroid or comet, the kind that could kill a quarter of the world's population, smashed into the ocean. And Paul, what is the estimated date when that occurred? Right there.
4,800 years ago, producing a tsunami 600 feet high.
Now, we're not talking about something here. Now, this was just basically released to the public yesterday. The discovery of an 18-mile crater, bottom of the Indian Ocean, that would have produced tsunami 600 feet high, and the dating of it appears to be no more than 5,000 years old. Now, if that turns out to be a correct date, we're seeing the most significant event clearly since the Ice Age ended. I mean, there's no two ways around it. This would be the most significant event of the last 10,000 years. And that would have had global consequences.
How high was the tsunami, what, 2 years ago, 3?
What was it, 15 feet?
15 feet.
Oh my God. You told me one at 600.
Yeah, today they were all worried about the 16 inches.
Yeah.
Yeah.
Most astronomers doubt that any large comets or asteroids have crashed into the Earth in the last 10,000 years. But the self-described band of misfits that make up the 2-year-old Holocene Impact Working Group say that astronomers simply have not known how or where to look for evidence of such impacts along the world's shorelines and into deep ocean. This was something that came out yesterday. The discovery of an 18-mile wide crater on the bottom of the Indian Ocean that appears to be 4,800 years old. And I'm showing I found an equivalent sized crater here, which you can see the enormous destructive potential of an object.
Is that up near the North Pole? Or
This is not the crater that was discovered.
no.
Right, this is in Newfoundland.
Oh, Newfoundland.
Yeah, and it's 17.5 miles in diameter, so it's very close to the size of the crater discovered on the bottom of the Indian Ocean. And the point here is that this energy was equivalent to 200,000 megatons. So we're faced with the possibility that, if this turns out to be true, it will absolutely require a rewriting of human history. No question at all. The Holocene Impact Working Group.
Part of that?
No, I'm not.
What would it do to the land, like, besides be underwater and stuff?
Well, it would have carried, now see these chevrons, let's see if I have okay, let's pass this around. This gives you an idea of what these chevrons are, these 600-foot thick or 700-foot thick deposits. that were washed onto land by this wave. Scientists in the working group say the evidence for such impacts during the last 10,000 years, known as the Holocene epoch, is strong enough to overturn current estimates of how often the Earth suffers a violent impact on the order of a 10 megaton explosion. Instead of once in 500,000 to 1 million years, as astronomers now calculate, catastrophic impacts could happen every few thousand years. Now let that sink in. The researchers who formed the working group after finding one another through an international conference are based in the United States, Australia, Russia, France, and Ireland. They are established experts in geology, geophysics, geomorphology, tsunamis, tree rings, soil science, and archaeology, including the structural analysis of myth. Their efforts are just getting underway, but they will present some of their work at the American Geophysical Union meeting in December in San Francisco. That's something I'm going to be paying attention to. This year, the group started using Google Earth. How many of you have ever used Google Earth? Boy, this is an amazing tool. A free source of satellite images to search around the globe for chevrons, which they interpret as evidence of past giant tsunamis. Scores of such sites have turned up in Australia, Africa, Europe, and the United States, including the Hudson River Valley and Long Island. When chevrons all point in the same direction to open water, Dallas Abbott, an adjunct research scientist at Lamont Doherty Earth Observatory, uses a different satellite technology to look for oceanic craters. With increasing frequency, she finds them, including the especially large one dating back 4,800 years. I haven't even had really time to do anything but scan this since I found it. William Ryan, a marine geologist at Lamont Observatory, compared Dr. Abbott's work to that of other pioneering scientists who had to change the way their colleagues thought about a subject. Many of us think Dallas is really onto something, Dr. Ryan said. She is building a story just like Walter Alvarez did. Who was Dr. Alvarez? Who was Walter Alvarez? The Alvarez team. They discovered the iridium layer at the KT boundary.
That's right.
Walter Alvarez.
That's right.
His father was Luis Alvarez, the famous Nobel Prize-winning physicist. What we're doing is I'm reading something that was came out yesterday, the discovery of a 18-mile in diameter impact crater on the bottom of the Indian Ocean that apparently created a 600-foot tsunami, and it's dated at 4,800 years. So it's part of this whole scenario of rethinking how often catastrophes actually happen. And so this is all evidence suggesting that there have been a considerably greater number of cataclysmic events just in the last 10,000 years than anybody had previously realized.
What's the most recent one?
The most recent what?
Giant comet.
Well, this would be
How far in would a 600-foot tsunami
How
come?
much land mass would it?
20 miles?
depends on the land. If it's like that would probably completely wash over Florida, because Florida is all pretty much below 600 feet.
53 feet is the highest in Florida.
Yes, that's what I'm saying. It's completely under. So
Right.
Florida would get completely washed. But, you know, we're 1,000 feet above sea level here. So my guess is it would probably like Macon. That's exactly what I was about to say. Macon would it would reach the fall line. So Savannah, Charleston, all of those would be pretty much washed out.
How do they determine it was 600 feet tsunamis?
Because they have found the deposits of it. And by studying the thickness of the deposits and how far inland they are, plus then also the physics of it. If there's an 18-mile diameter crater, you can assume that the object that created it is probably a mile in diameter. So then by assuming a mile object crashing into the ocean, how big of a wave would that produce? So on the one end, you have a theoretical way of producing it. Then on the other end, you've got field evidence where you can actually see the wash. And what they've been doing is they've been studying these things called chevrons, which are sedimentary deposits. And in this particular event, it's in Madagascar.
Which one are you talking about? The one in Iraq or the one in the...
The one in Iraq is on the land, and it's 2 miles wide. And it appears to be 6,000 years old. The one in the Indian Ocean is 18 miles wide and appears to be only 4,800 years old.
Not 4,800 BC, but 4,800 years ago.
4,800 years ago. Now, I'm curious myself to see how it was dated. Oh, well, I'm going to guess that it was probably dated by looking at organic material in the chevrons themselves. That's what I'm going to guess. Ted Bryant, a geomorphologist at the University of Wollongong in New South Wales, Australia, was the first person to recognize the palm prints of mega tsunamis. Large tsunamis of 30 feet or more are caused by volcanoes, earthquakes, and submarine landslides, he said. And their deposits have different features. Deposits from mega tsunamis contain unusual rocks with marine oyster shells, which cannot be explained by wind erosion, storm waves, volcanoes, or other natural processes. We're not talking about any tsunami you've ever seen, Dr. Bryant said. No tsunami, and he's referring to the tsunami features on Madagascar. No tsunami in the modern world could have made these features. For example, Dr. Bryant identified 2 chevrons found over 4 miles inland in north-central Australia. Both point north. When Dr. Abbott visited a year ago, he asked her to find the craters. To locate craters, Dr. Abbott uses sea surface altimetry data. Satellites scan the ocean surface and log the exact height of it. Underwater mountain ranges, trenches, and holes in the ground disturb the Earth's gravitational field, causing sea surface heights to vary by fractions of an inch. Within 24 hours of searching the shallow water north of the 2 chevrons, Dr. Abbott found 2 craters. Since not all depressions in the ocean are impact craters, Dr. Abbott said, a check is needed. So she obtained samples from deep sea sediment cores taken in the area by the Australian Geological Survey. The cores contain melted rocks and magnetic spherules with fractures and textures characteristic of a cosmic impact, which is what you would look for. Melted rock, shocked quartz, which only happens under tremendous pressure, microspherules, again, which are part of when something vaporizes and it comes back down onto the surface of the Earth, there will be these, they're called microspherules because you can't even, they're smaller than grains of sand, but when you look at them under a microscope, they're shiny and glassy and almost perfectly round. And that is one of the characteristics of an impact. The cores contain melted rocks and magnetic spheres with fractures and textures characteristic of a cosmic impact. The rock was pulverized like it was hit with a hammer, Dr. Abbott said. We found diatoms fused to tektites. Now that's the first time I've ever heard of that. You know what a diatom is? That's a little shelled creature that lives in the ocean. You know what a tektite is, right? Tektite is part of the splash of a cosmic impact. It's usually composed of whatever the target rock is, plus whatever the composition of the impactor is. It all melts together in this tremendous big boiling stew, and it's thrown out into the atmosphere. And as this stuff rains back down to Earth, it solidifies into these aerodynamic shapes, which are called tektites. And I've said several times, and I will say again, you guys should go over, some of you should go over to the Fernbank Science Center and look at the collection of tektites they have over there. And Georgia, you know, from that Chesapeake impact that we were talking about earlier, Georgia was directly under one of these cosmic rains of this molten material, creating the Georgia Tektite field. They're found more south of Macon, because you have to get where the Eocene rocks below and the Oligocene rocks above, because it was during the Eocene, 35 million years ago, when the splash came down. Okay, in the last 35 million years, there have been, hundreds of feet of sedimentary rocks laid down on top of the land surface that received that cosmic rain of molten metal. So you have to go wherever that sandwiched layer is exposed. And there's along the fall line south of Macon is where you find that. But I don't know what's up there near Canton. Well, as it turns out, the preliminary dating on these two Australian craters makes them appear to be 1,200 years old. So again, what's happening, if you followed the trend of the science of impact geology in the last 20 years, what you'll see is it's gone from something that is of geological interest, but not necessarily historical interest, 20 years ago. Now, on the other hand, it's suddenly emerging as a major factor in understanding human history. Certainly, if these events have happened with the kind of frequency that this new data is implying, it has played a major role in human history. And I mean, there's no way that an event that produced an 18-mile crater couldn't have had a major effect, not only on the global climate, but, if there was any emergent Holocene civilization, 5,000 years ago, I think it would have been pretty much set back to Stone Age.
Were there any myths that substantiate that 4,800, 5,000 years ago?
Well, certainly flood myths. Yes.
It's kind of like that question. I'm sure you've talked, but when was the Great Flood? The Noah's Ark thing?
Well, I have generally interpreted the Noah's Ark thing as going back to the end of the Ice Age, because the most well-documented globally cataclysmic floods were at the end of the last Ice Age.
But with this new information...
But this new information could imply... But what Plato says, what has Plato said? Plato says, and this I think is being confirmed by modern evidence, is that there were numerous cataclysmic floods in the ancient world. And our ancestors probably suffered through more than we even begin to suspect. In fact, I would suspect that what this new information is probably showing us is that our species has probably stood on the brink of extinction multiple times. I mean, how could an event that was equivalent to 13.3 million Hiroshimas not have had enormous consequences for the human race and the global climate?